Python, because it kind of relies on this object-oriented approach. It's a bunch of buzzwords for saying stuff belongs to other stuff. So even now what we do is we create an object, and it has two kinds of properties. It has variables associated with it, and it has methods. Methods are just functions, which once again belong to the object. So we can create a class of a person. They can have variables of name, age, and address, and we can create methods for us to interact with that object. We can create functions that we can call as part of that object to get some data, perform an action. So we might have say name, age might be get older, we might have the address as change address. So what I'm going to do now is I'm going to go back to VS Code and I'm going to create a class, which is we create this in code and walk through how I would do that. And if you guys want to follow along, that's probably ideal.
And just so you guys have a little bit more intuition as to what methods can mean, a second ago you used the clear method for clearing your list. That is exactly the same thing as what we'll be looking at.
So what's the difference between function and method?
A method belongs to an object.
A function you could call from anywhere in the script.
Right.
A method only works if you use it on the right object.
So that's the period.
So if you see here, we've got B and we've got B equals clear list.
Right.
If I had to say, what could a list belong to?
So it basically just does the same thing, but with
Shopping.
within different.
If I'd say shopping.clearList, that would be a method. But there is a distinction in how we use them, and there's a distinction in the fact that clear list doesn't know anything outside of what's defined in its own function, whereas when we create methods, which you'll see in a minute, they actually have access a lot of the time to variables associated. So the idea is that if we just had, I'll go back to the example, if we had a method that was, say, the name, if we just had this set up as a function, I'd have to pass in the name to say. I'd have to say, you say your name and your name is Josh. Mm-hmm. Whereas if this belongs to a person, if this belongs to an object that already has that name saved, okay. I can say name, and it'll go, oh, your name's Josh.
Okay.
But I could have 50 other objects with all have different names, and I could call the same thing, but it'd give me a different name every time.
I think I get it.
Kind of makes sense. Well, I think it'll become more obvious if we start writing it out.
To add on, so the idea with classes is that you can kind of insulate what happens within a class. So by having a method, you can make sure that a function is only going to do the thing that you want it to do to that object.
Yeah.
Whereas if you've got, let's say again, like you're building like Facebook, for example, you've got bits of code lying everywhere, you've got lots of functions all over the place. By using object-oriented programming and using an object, using a class to create an object that has a method, you make sure that you don't break something over here by doing something over there, if that makes sense. And as Josh was saying, it can make it nice and concise if you do it smartly.
Okay. So what you have, which we'll construct, so you create a person, this is technically a class. It doesn't have anything in it yet. So the main thing you want with a class is you want something called a constructor, which is when I'm, just to go back, where this is, again, this is like a function, it's not read by the code until we call it. Mm-hmm. So what we would do is we'd say person, how is it with Python again? What is it?
What do you want to do?
What do you, when you're defining an object, what's it with Python again?
Underscore, init.
Not for the init, not for the inits, the...
Self dot.
It's never mind, it's fine. Okay, it's just like you were defining a function.
Oh, that's what you're trying to do. You're trying to call the...
I'm just trying to create an object. It's fine. Yeah, like I say, my brain is on C++.
That's fine. I remember when my brain was on JavaScript, and then everything I did in Python was just crap.
So I'm gonna say, because I'm self-centered, so.
You're a narcissist, so
right. This could very easily look like a function, because right now it makes no sense, and because how many months that does. I love. It's so fun, isn't it? Okay, this is one of the only functions you'll have in Python that you definitely have to name a certain thing. Sort of going back on our own rules again. And we'll have to have self in there. So this is a constructor. When I call this, when I say Josh equals a person, there's a bit of code that needs to run here. We basically need to assign those variables we were looking at a minute ago. We need to create variables that are name, age, and address. So we'll do that in this constructor class, which is the initialization class. So what I will do, and we'll get into it in a minute, but just trust me, is you have to basically say self. So self dot name equals, once again, self dot age equals 20. I'm not 10. That would make some things between us a little different. Sorry. Okay. Now I can run this, and I'm going to delete all the code from before because it makes it a mess. And as you can imagine, well, actually, question: what do you think is going to happen when I run this? What do you think my output's going to be?
It's not going to work.
You're cheating. You know it's not going to work because nothing I make works.
I think it'll output none.
You can be quiet, right? Anybody here that's here today, what do you think is going to happen? Fine, okay. We'll find out. Yeah, there's shit all. Because I'm not actually calling it to do anything. Because I've assigned these variables, but I'm not doing anything about them. What I can do is I can say, what was one of the functions we said? Say name. So I can create a function in here that is say name. And I'm again going to have to pass in this self. Because that is how in Python with classes, we essentially get all this information that is contained within the object. So I'm going to just say print. That says pint. Thinking too much. It's where I'm after this anyway.
Freudian slip. Huh?
Right. And again, this will also do nothing. What I have to do is I have to say Josh dot say name. Say name.
Yep.
So now what's going to run? We're going to create this object, which is person. We're going to create this person. We're going to have their name be Josh, because I've got that by default. I do not have to have this by default, which we'll get onto in a second. And then I'm going to call it to say its own name. Do I run that? There we go. It's printing its name. But I could also, for example, create another function, which is def change name. And this is kind of where you'll start to get a feel for why classes are used so much in Python. Is because what we can do is just say name equals self.name. No, actually, we're going to be fancier than that. No, because that's not clear. New name. Okay. And then we will create a person. We're going to ask to say their own name. We are then going to do, this is the idea is that we can call another function and we can change name and we can pass things into it. So we might pass in that their name is not Josh. Yeah, I'm not very good at typing, it turns out. And then we're going to ask him to say it again. And what we'll find is we can run that. We've now changed their name from outside of the class.
One thing that kind of confused me very early on is that when you're working with methods for a class or an object, it will just ignore the self thing. Like, it is set up to like look at the things you've given it, so self and new name, and it's like self, okay, cool, I'm gonna put this in one pile, and then it will work through the variables after that. Does that make sense?
Yeah. So in a normal function, the idea is that when we call this function, we don't need to put in like a self. This is kind of by default the first term in this function definition. It's always going to be looking at itself. It's going to be looking at the variables it contains, which we've defined and set up as name and age. Okay. Is there any questions on this bit specifically?
Is the bit in the brackets, is that like the input?
Yes.
to the
So,
function?
yeah, exactly.
And the whole thing is a method?
These sections are methods. So this is one method. This is another method.
Okay.
This is another method.
But they're also functions?
So methods are functions.
Okay.
So again, we'll go back. The basic idea is that you have an object has two kinds of things it can have. It can have variables or it can have methods.
Yeah.
Those methods are functions that are specific to those objects, to those classes.
Okay, so the object is the class?
Yeah. It's a bit of a weird thought to get your head around because we've just learned about functions, but just treat it as a function that belongs to a class.
Yeah, I just think I wasn't sure what the class was.
That's fine, yeah. It's a data structure. It's just an idea that we can group these things together.
Mm-hmm.
Yeah.
And then the output is the bits at the end.
The output, sorry. So for an output, we can either, typically when we do functions, we use the keyword return, which isn't present in here because we never actually
But this is still an
return
output.
it.
It's
Yeah.
an output of
Well,
sorts because you can see it.
what I could do is when I say name change, what I could do is I could say return true,
You could do return name.
return name, self.name.
Yeah.
And then what I could do is when I do self.name, I can actually say
You can
print.
Yeah.
So instead of doing this, I could say, again, this is going to get a bit long because you typically might not do this way. But we can print. Yeah, so the idea is that the value being returned, so this entire section here, essentially becomes a variable or it becomes a value when we use a return keyword. We can put that into a print statement, and if we run this, it should have pretty much the same output, which is, yeah.
It does.
So we don't need to tell like the function to end, it will just...
It will automatically end when it gets to the end of that line of code. As soon as it gets to here and it passes on, it goes, oh, I'm done here. It returns back to wherever it was. So just stepping through, we'll create the name, which will take us into this. It is quite of a weird thought to get your head around, which is where you kind of want to develop a sense of where the code is running, where it is. So it will initialize the function, it sets the name, it sets the age, and once it's done here, returns back. And it'll go to the next line that it hasn't run yet. So then it'll say the name. It'll go here, it'll print the name, it'll go over here, and it gets a little bit more confusing because we've nested these statements within each other. But we'll say print, it'll want to know essentially what this does, what the value is, because it's expecting a value that it's able to print, and it goes, it must return something. Let's see what it returns. Okay, we changed the name. Oh, it's returned a name. We'll send ourselves all the way back, and we print that value. Yeah? Okay. Do you guys want to just try writing that yourself?
I had a question.
Yeah.
I don't really understand the line 7 when we wrote same name.
Yeah.
Like, I obviously was, I thought it was like here, so I
Yeah, it's fine.
But I don't understand what the point of it is. Because if you're just trying to, well, from what I can see, it's just like you're assigning Josh to as a variable of the name.
Mm-hmm.
But if your output is just wanting to print the name Josh,
Mm-hmm.
could you just print the name Josh?
You could.
In quotes,
No, you're 100% right.
But also,
The
like, if you want to make variables, could you just, like, f-string those variables or something?
Yeah, you're kind of getting to the point that there is 1,000 ways of doing everything.
Yeah.
But the idea is that you might not use this directly, but when you get into like managing large amounts of data, for example, or you get into creating applications, a lot of the time there is a lot of things you want to manage, and it's a really good idea to keep those compartmentalized. For example, if I had 1,000 people, I had a register of 1,000 people, and they all have names, they all have addresses, it could be quite confusing. If they wouldn't just have that, so there's 10 different data points they all have. If we had to keep all of that information in 10 different lists, and then to do that, we'd have to make sure that each of those people are, if we had person name, and we had these lists, which is what you're getting at, and then we have we could have all these different values that we basically have. And then the problem with this is that when we want to associate the correct name to the correct person, or the correct age to the correct person, we've got to make sure that all of these are in order.
Yeah.
It's quite hard to manage. Whereas if we can just create an object, and then we just say, object.age, object.name, we get those values from it, it's really easy to manage data. Yeah, I think that's the core reason that if you guys with neuroscience or anything kind of bioscience would really use it, would be for managing data and holding these values for large amounts of data sets.
What's the advantage of doing it here than like Excel then?
Doing it here than Excel.
Because we have to input the data regardless.
You could have to input the data. The advantage of Python is its libraries. So it has hundreds, thousands of different libraries that you can use that essentially are just pre-written blocks of code to do rather complicated things. So an example that I can use is one of the things I've been using Python for recently is we have this EEG headset, which I'm not going to be able to pull up the example because it's stopped running on my computer. Don't ask me why. If somebody wanted to donate their computer, I could run it just fine. But we have this EEG headset. This pulls in 500 samples per second from each electrode.
Right.
It's 4,000 data samples per second, 4,500 including the time steps.
Yeah.
And I want that to run in real time. I want to be able to graph that and see that. Good luck doing that with Excel. It would be quite difficult to manage that amount of data procedurally, step after step. But you're right. There is like a point where you just if this task is so simple, why not use Excel? But the point is, it's scalable.
Yeah.
The advantage is that we can create much more complicated programs, and you can scale that up.
Sorry, I didn't maybe understand the actual sequence of commands that make, because you mentioned that you wanted to assign the integers or numbers of something to names.
Yeah.
So like a script, then how would we order it to be like, let's say it was 1, 2, 3, and then it was like Alex, Josh, someone. How would I, or is this the code that assigns those names to the numbers in order? Is that what that is?
This is not what would do this. The point of example is are you asking about these lists at the top now? Yeah. So this was my example of the idea that not using classes or not using similar data structures doesn't scale very well. Because if these were 1,000 long and you had to make sure that each one of those matched up, that's quite a difficult task. Whereas if you keep them in classes or similar data structures, we can keep them quite compartmentalized. So how is because what we'd say is we've got Josh as a person, but I could also say Hugo is also a person. Right? And I can add as many as I want. In fact, I can go through, I don't need to necessarily call them names. I can say for I in range 0 to 100. So I can create 100 people. And I just say I equals person. Yeah.
So you're defining that all of the numbers in there are
So each number I mean, you might do this in a much nicer way. This is not very readable, but the idea is that now we can create 100 people, all of which have names and addresses, but also crucially, which we can individually change those names. So this is probably the better example. If I wanted to change the name of the person, I wanted to change the age of the person, of person 58, I'd have to iterate through all of this, find that person, I'd have to then iterate through this, change that. Whereas here I can just say, create a function, change age. And I can just say, person 58, change age. Kind of makes sense? Kind of not? It isn't weird until you start sort of using it and applying it in larger scale sort of, it kind of, you look at it, you go, it's a lot of faff for nothing. And there is a point that if you're doing small data sets, use lists. Use smaller data structures, things that are easier to manage. But quite quickly you'll find that you'll get errors that are, you're accessing a data point that doesn't exist, or you're accessing this doesn't match. Yeah, sorry. Okay. Cool. We'll do a little bit on a little bit of fun, which is on there as well. There is just to sort of go on to the idea of libraries. So this is a pretty simple one. This is Matplotlib. Have anyone used MATLAB? Yeah, poor soul. But this is Python's version of that. It's using the same backend. So the idea is that we can import matplotlib.pyplot as PLT, which is a mouthful, but it basically just means we're importing this section. So we're importing this section of this library, and then we are calling it PLT, so we don't need to say this every single time. We can create a variable x, which is just a list of I divided by 50 for I in range of 500, so 500 data points. It's just, I mean, it's kind of written in a strange way, but we're creating a bunch of data points there that range from 0 to 5, for the 500 data points, all between 0 and 1, and then we are plotting it. So if I run this, we can get an output that looks a lot nicer than if it was just, so there we go. We can use libraries like this. And again, the advantage of using Python is that there are graphing libraries, there are input libraries, you can export to like every data format imaginable, you can do 3D modeling, whatever you need to do. The point is that there is probably a library for it. So it's just a library to plot it, we create a sine wave. But you can imagine that to be any sort of EMG data, any data set you're working with. But yeah.